Hey folks, Ms. Gosling here. In this video, you're going to learn about nuclear power. By the end of the video, you'll be able to quantitatively analyze the energy provided by nuclear power. So nuclear power is when we use the energy stored within the nucleus of an atom to generate electricity. So our nuclear power stations actually have a lot in common with our traditional fossil fuel power stations in that what we're doing is we are using the energy stored within the nucleus of an atom to heat up water, which we then use to rotate a turbine and generate electricity. So some pros of nuclear power. Nuclear power does not exacerbate climate change, so we don't have any greenhouse gases getting released. We need fewer raw materials since our fissionable isotopes are really, really energy dense. So you don't need a lot of uranium to be able to generate a significant amount of nuclear power. Another thing I want to mention is that nuclear power, the materials we use in nuclear power are not renewable, but they're harder to use at a rate where we can't use, it's harder to use them so quickly that we worry about running out of them. So we need a lot of oil or coal or natural gas to generate power. We don't need as much uranium as compared to the quantity of uranium on the planet. But there are some significant cons related with nuclear power. So first of all, we need some significant safety measures due to the danger of nuclear meltdowns. You guys have all heard of Chernobyl or 3 Mile Island or the Fukushima disaster, and all of this is what happens when the safety measures of our nuclear power plants fail. So if the consequences of failure are so significant that nothing can live there for hundreds of years, it's important that we ensure that we have very, very top-notch safety measures. Another key con is that the waste products last a long time and need to be stored. And finally, the materials that we use for nuclear power, so our enriched uranium, can also be weaponized. So the level of uranium enrichment needed for nuclear power is between 3 and 20%. If something is enriched between 20 and 85%, we can use that level of enriched uranium to actually create nuclear weapons, which of course is a significant international concern. So the math for nuclear power we just covered in the previous unit on nuclear energy. So what we'll do is we'll look at the mass difference between the initial U-235 atom and the things that are created from it. We multiply that by c squared, and we can figure out the energy generated in one nuclear reaction, and then we can multiply that by the mass of uranium by the number of atoms of uranium that are being split apart at the same time. So let's go ahead and look at an example. So when one U-235 nucleus undergoes fission, 320 nanojoules of energy are released. If the density of U-235 is 1.9 times 10 to the 4th kilograms per meter cubed, calculate the specific energy of U-235. So since this is uranium-235, we know that the mass of one atom is equal to 235 atomic mass units, or that the mass of the atom is 235 AMU times 1.67 times 10 to the negative 27th kilograms per atomic mass unit. So the mass of one atom of uranium is 4 times 10 to the negative 25th kilograms. So I know that my specific energy is equal to the joules released per kilogram of material. So that's going to be equal to the energy released per kilogram of uranium, which is going to be given by 320 times 10 to the negative 9th joules released per atom. And one atom has a mass of 4 times 10 to the negative 25th kilograms. Now, if we wanted to do this in kind of the way that you learned it in chemistry, what we could write is that we have 320 times 10 to the negative ninth joules per atom. And then we could say that the mass of one atom has a mass of 4 times 10 to the negative 23rd kilograms. And there we go. But I prefer this simpler way of doing so. And so what we can do is we can say that the specific energy of uranium is equal to 320 times 10 to the negative ninth divided by 4 times 10 to the negative 25th kilograms. Thus, the specific energy of uranium in this instance is 8 times 10 to the 17th joules per kilogram. And there you have it. Now, one quick thing I did want to talk about before finishing this video up are some of the important components of a nuclear power station, because they are a little more complex than your traditional thermal power station. So first of all, we need to ensure that we have enriched uranium, which is uranium in which 3 to 20% of that uranium is U-235 versus our natural uranium in which less than 1% of the uranium atoms are that fissile U-235. So the second thing that we need is something called a moderator. And a moderator slows down the speed of the neutrons released by nuclear fission, which allows them to be used to sustain the reaction. So if our neutrons released by nuclear fission are moving too quickly, then they won't be able to cause other uranium atoms to break apart. So our moderators need to be used to slow down those neutrons, allowing them to interact with other uranium-235 atoms. And our moderator is usually either water or graphite. The third key thing of a nuclear power station are the control rods. And those control rods are made of boron or another material that absorbs neutrons really easily. And the goal of our control rods is to reduce the rate of nuclear fission by absorbing stray neutrons. So usually our control rods can be lowered into our nuclear reactor or raised up out of it in order to ensure that the rate of nuclear fission is constant. And then finally, we have the heat exchanger, which carries energy from the reactor to the turbines. And the goal of our heat exchanger is to prevent any radioactive material from actually leaving the reactor. So quickly, some takeaways. Nuclear power uses the energy stored in the nucleus of a fissionable atom to generate electric power. Nuclear power is non-renewable, but does not generate greenhouse gases. However, there are environmental, social, and international concerns regarding the use of nuclear power. The power generated by a nuclear power station depends on its efficiency and on the rate of the nuclear reactions. And moderators, control rods, and a heat exchanger are used to ensure that nuclear power plants are self-sustaining and safe. So there you have it, folks. That is your introduction to nuclear power. It is your turn now to try solving some problems on your own. Best of luck and happy solving.